Grounding metal veneers on buildings is essential for safety and compliance with building codes. Chapter 27 of the International Building Code and the ICC Electrical Code address these requirements. This discussion will cover methods for grounding metal veneers, bonding procedures, and additional considerations. Firstly, bonding to a lightning protection system or LPS. A pro for this method is that the LPS is designed to safely discharge lightning currents. Another pro is that this method eliminates the need for additional grounding systems. However, a con is that it's not always feasible for buildings without an LPS. Also, it may require approval from the lightning protection installer. Secondly, bonding to structural steel. A pro is that structural steel provides a solid grounding path. Another pro is that it's relatively simple to implement. A con is that it's not always accessible, especially for high-rise buildings. Also, it may require drilling or welding into structural members. Thirdly, using a dedicated grounding system. A pro is that an independent grounding system ensures effective grounding even if other systems fail. Another pro is that it provides flexibility for buildings with different configurations. A con is that it requires additional materials and installation time. Also, it may be more expensive than other methods. The most appropriate method depends on specific building design and conditions. However, for most situations, bonding the metal veneers to the lightning protection system is the preferred approach due to its simplicity and effectiveness. Here is the bonding procedure. 1. Use copper straps or cables with a minimum cross-sectional area of 10 mm², which is about 6 American wire gauge. 2. Bond the metal veneers to the lightning protection down conductors at multiple points. 3. Ensure that all connections are secure and have low electrical resistance. 4. Test the grounding system to verify its integrity and grounding resistance. Additional considerations include corrosion protection. Use corrosion-resistant materials for bonding and connections to prevent degradation. Also, electrical isolation. Insulate bonding points to prevent inadvertent electrical contact with other building components. Coordination with the architect and contractor is also important. Ensure that the architect and contractor are aware of the grounding requirements and coordinate their work accordingly. Let's delve into each grounding method in more detail. Starting with bonding to the lightning protection system or LPS. This method involves connecting the metal veneer panels directly to the existing lightning protection system. The LPS is designed to provide a safe path for lightning currents to ground, and by bonding the veneer panels to it, you can ensure that any electrical charges induced in the panels are safely discharged. The primary advantage of this method is that it utilizes an existing system, potentially reducing the cost and complexity of the grounding installation. However, it's crucial to verify that the LPS is adequately sized and designed to handle the additional load from the veneer panels. Furthermore, you must obtain approval from the lightning protection installer or a qualified engineer to ensure that the bonding process does not compromise the integrity of the LPS. To implement this method, use copper straps or cables to connect the veneer panels to the LPS down conductors. Ensure that the connections are made at multiple points along the building's facade to provide a consistent and reliable grounding path. All connections must be secure and have low electrical resistance to effectively conduct electrical currents. The size of the copper straps or cable should be determined based on the anticipated current load, but a minimum cross-sectional area of 10 mm² or 6 American wire gauge is generally recommended. Next, bonding to structural steel. This method involves connecting the metal veneer panels to the building's structural steel frame. Structural steel is typically well grounded, providing a reliable path for electrical currents to dissipate into the earth. This method is relatively simple to implement, as the steel frame is usually readily accessible during construction. However, it's essential to ensure that the structural steel is properly grounded and that the connections between the veneer panels and the steel frame are secure and have low electrical resistance. To implement this method, use copper straps or cables to connect the veneer panels to the structural steel members. The connections should be made at multiple points along the building's facade to provide a consistent and reliable grounding path. Drilling or welding may be required to attach the copper straps or cables to the steel frame. Ensure that all connections are properly protected against corrosion to maintain their integrity over time. Now, let's review dedicated grounding systems. This method involves installing a separate grounding system specifically for the metal veneer panels. This system typically consists of ground rods or ground plates buried in the earth and connected to the veneer panels via copper conductors. A dedicated grounding system provides an independent grounding path, ensuring that the veneer panels are effectively grounded even if other grounding systems fail. However, this method requires additional materials and installation time, which can increase the overall cost of the project. To implement this method, install ground rods or ground plates around the perimeter of the building, ensuring that they are in contact with the earth. Connect the ground rods or ground plates to the veneer panels using copper conductors. The size and spacing of the ground rods or ground plates should be determined based on the soil conditions and the anticipated current load. Ensure that all connections are properly protected against corrosion to maintain their integrity over time. Regardless of the grounding method chosen, it's crucial to follow a consistent bonding procedure to ensure that the metal veneer panels are effectively grounded. This procedure typically involves the following steps. First, use copper straps or cables with a minimum cross-sectional area of 10 mm² or 6 American wire gauge to connect the veneer panels to the grounding system. The size of the copper straps or cables should be determined based on the anticipated current load. Second, bond the metal veneers to the grounding system at multiple points along the building's facade. This will provide a consistent and reliable grounding path. Third, ensure that all connections are secure and have low electrical resistance. This is essential for effectively conducting electrical currents. Fourth, test the grounding system to verify its integrity and grounding resistance. This will ensure that the system is functioning properly and that the veneer panels are effectively grounded. In addition to the bonding procedure, there are several additional considerations that should be taken into account when grounding metal veneer panels. These include corrosion protection, electrical isolation, and coordination with the architect and contractor. Corrosion protection is essential for maintaining the integrity of the grounding system over time. Use corrosion-resistant materials for bonding and connections to prevent degradation. This is particularly important in areas with high humidity or exposure to corrosive elements. Electrical isolation is also important to prevent inadvertent electrical contact with other building components. Insulate bonding points to prevent electrical contact with other building components. This will help to prevent electrical shocks and other hazards. Coordination with the architect and contractor is essential for ensuring that the grounding requirements are properly implemented. Ensure that the architect and contractor are aware of the grounding requirements and coordinate their work accordingly. This will help to prevent errors and ensure that the grounding system is properly installed. Let's further elaborate on the importance of using corrosion-resistant materials. When selecting materials for grounding metal veneer panels, it's crucial to consider the potential for corrosion. Metal veneer panels are often exposed to the elements, which can lead to corrosion over time. Corrosion can degrade the grounding connections, reducing their effectiveness and potentially creating a safety hazard. To prevent corrosion, use corrosion-resistant materials for all bonding and connections. This includes copper straps, cables, connectors, and hardware. Copper is a highly conductive material that is also resistant to corrosion. Stainless steel is another option, as it is also resistant to corrosion and can provide a strong, durable connection. In addition to using corrosion-resistant materials, it's also important to protect the grounding connections from moisture and other corrosive elements. This can be done by applying a sealant or coating to the connections. The sealant or coating should be compatible with the materials being used and should be able to withstand the environmental conditions to which the connections will be exposed. Now let's discuss the importance of electrical isolation. Electrical isolation is the process of preventing electrical current from flowing between different parts of a system or structure. In the context of grounding metal veneer panels, electrical isolation is important to prevent inadvertent electrical contact with other building components. If a metal veneer panel comes into contact with another built-in component that is energized, it could create a shock hazard. To prevent this, insulate bonding points to prevent electrical contact with other building components. This can be done by using insulating washers, bushings, or sleeves at the points where the copper straps or cables are connected to the veneer panels or the grounding system. The insulating material should be rated for the voltage levels that are present in the building and should be able to withstand the environmental conditions to which they will be exposed. In addition to insulating the bonding points, it's also important to ensure that the metal veneer panels are not in contact with any other energized built-in components. This can be done by providing adequate clearance between the veneer panels and other components, or by using insulating materials to separate them. Finally, let's emphasize the importance of coordinating with the architect and contractor. Grounding metal veneer panels is a critical aspect of building safety and should be carefully coordinated with the architect and contractor. The architect is responsible for designing the building and specifying the materials and methods to be used for construction. The contractor is responsible for constructing the building according to the architect's plans and specifications. To ensure that the grounding requirements are properly implemented, the architect and contractor should work together to develop a detailed plan that outlines the grounding system and the bonding procedures. This plan should be reviewed and approved by a qualified electrical engineer to ensure that it meets all applicable codes and standards. The architect should also ensure that the grounding requirements are clearly documented in the building plans and specifications. This will help to ensure that the contractor is aware of the requirements and can properly implement them during construction. The contractor should also ensure that all workers involved in the grounding installation are properly trained and qualified. This will help to prevent errors and ensure that the grounding system is properly installed. Throughout the construction process, the architect and contractor should regularly communicate to address any questions or concerns that may arise. This will help to ensure that the grounding system is properly implemented and that the building is safe for occupancy. In summary, grounding metal veneer panels is essential for safety and compliance with building codes. The most appropriate grounding method depends on the specific building design and conditions. However, for most situations, bonding the metal veneers to the lightning protection system is the preferred approach due to its simplicity and effectiveness. Regardless of the grounding method chosen, it's crucial to follow a consistent bonding procedure and to take into account additional considerations such as corrosion protection, electrical isolation, and coordination with the architect and contractor. By following these guidelines, you can ensure that the metal veneer panels are effectively grounded and that the building is safe for occupancy. Let's talk about some of the tools and equipment that are commonly used for grounding metal veneer panels. Firstly, copper straps and cables. These are used to connect the veneer panels to the grounding system. Copper is a highly conductive material that is also resistant to corrosion, making it an ideal choice for grounding applications. The size of the copper straps and cable should be determined based on the anticipated current load. Secondly, connectors. These are used to connect the copper straps and cables to the veneer panels and the grounding system. Connectors should be made of corrosion-resistant materials and should be designed to provide a secure and reliable connection. Thirdly, grounding rods and plates. These are used to create a dedicated grounding system. Grounding rods are typically driven into the earth, while grounding plates are buried in the earth. The size and spacing of the grounding rods and plates should be determined based on the soil conditions and the anticipated current load. Fourthly, drilling and welding equipment. This equipment may be required to attach the copper straps and cables to the structural steel frame. Fifthly, testing equipment. This equipment is used to verify the integrity and grounding resistance of the grounding system. Testing equipment typically includes a ground resistance tester and a multimeter. Now let's delve a little deeper into testing and verification. After installing the grounding system, it's crucial to test and verify its integrity to ensure that it is functioning properly and that the veneer panels are effectively grounded. There are several tests that can be performed to verify the integrity of the grounding system. One common test is the ground resistance test. This test measures the resistance between the grounding system and the earth. The resistance should be as low as possible, ideally less than 25 ohms. A higher resistance indicates that the grounding system is not properly connected to the earth and that it may not be effective in dissipating electrical currents. Another common test is the continuity test. This test verifies that there is a continuous electrical path between the veneer panels and the grounding system. This test can be performed using a multimeter. The multimeter should be set to the continuity setting, and the probe should be placed on the veneer panels and the grounding system. If the multimeter indicates continuity, then there is a continuous electrical path between the veneer panels and the grounding system. In addition to these tests, it's also important to visually inspect the grounding system to ensure that all connections are secure and that there are no signs of corrosion or damage. Any issues that are identified during the testing and verification process should be addressed immediately to ensure that the grounding system is functioning properly. In conclusion, grounding metal veneer panels is a critical aspect of building safety and should be carefully considered during the design and construction process. By following the guidelines outlined in this discussion, you can ensure that the metal veneer panels are effectively grounded and that the building is safe for occupancy. Remember to consult with qualified electrical engineers and building professionals to ensure that the grounding system meets all applicable codes and standards.